Hello, and welcome to our program, Astronomy for Everyone. Due to the current state of the COVID 19 epidemic, we're producing our show remotely. Now, before we begin, I want to give a big shout out to all the healthcare professionals and first responders who are working diligently to keep us all safe. Thank you. Our guest for this show is Doug Bott, a member of both the Ford Amateur Astronomy Club and the Warren Astronomical Society, along with a couple of other clubs as well. And in addition, he's also an accomplished astro imager. Doug, welcome to the show.
Thank you, sir. Glad to be here.
We'll begin by watching a time-lapse video showing how you built your observatory. Doug, fill us in on the details, please.
Well, first of all, the original observatory was built in 1984 when I moved out here to the country, and it lasted about 34 years. And I decided to tear it down and have a rebuild because it was showing its age. So this is the new build that happened when I had a backyard observatories company come up from Ohio and build a new version on top of this platform. So I'll start this time lapse up and describe a little bit of what I have going on here. So the type of scope that I have in this building is a Ritchie-Chrétien, which is it's a 10-inch f8 telescope that I use for imaging, and I have a pair of ZWO cameras for both image acquisition and guiding. I have the power to the building comes from the house via a trench I dug back in 1984 that's about 150 feet long, running underground cable of 30 amp power to the building. So I can plug everything in and run with electrical. I do have a UPS out there to clean the power up before it actually gets to any of the equipment. The observatory itself, it can be operated both in the building or back at the house 150 feet away in my den remotely via Wi-Fi. The laptop I have out there runs the entire system, so I don't have to actually be logged in the den to run it, but I can connect to it remotely if I wish to. And then I can script up the system to work all night and collect data all night while I'm sleeping if I want. And I do that so that I can take advantage of the few clear nights that we have here in Michigan, especially when it's a weekday and I have to go to work the next day. So I can run it, start it up, run it, and then go to bed, and then check in the morning and download all the data. And finally, I have a roll-off roof that does not get in the way of the scope because it's far enough north and the scope is high enough that I can see Polaris. And that means that I can see all the objects from Polaris over the zenith and into the south. The building also has a fold-down segment in the south that's about 2 feet, so I can get a lower horizon in the south. The the next segment would be basically I'm going to be talking about imaging and how and what are processing the images that I download. In the morning, I usually download all the data, maybe take some flats, and maybe take some darks, and I'll actually describe a little bit of that.
I see you've got an electric motor to open and close the dome. Does that have a sensor in case it starts pouring in the middle of the night?
No, actually, no. I don't have a weather station or automatic closure yet, but it is in the plans to do so. I've actually gotten caught a couple of, or at least once, with a little bit of snowfall come into the building this last week, which was unanticipated. It was supposed to be clear all night, and it actually clouded up around 2. So that's in the plans to do, and I'm just have to get the pennies together to do that.
Yeah, that's usually the case with any type of a project like that. Well, this has been very interesting, Doug. And right now, we're going to take a quick break to find out what Stephen has for us in Term of the Month. Stephen?
The term of the month is Crab Nebula. John Bevis discovered the Crab Nebula in 1731. The Crab Nebula name came from Lord Rosse, who sketched it using a 36-inch scope in 1844 and noted that it resembled a crab. 4 years later, though, he observed it in a 72-inch scope and no longer saw the resemblance. The name stuck anyway. Charles Messier saw it when looking, in vain, for the return of Halley's Comet. At first, he thought it was the comet. Then he noted that it wasn't moving. The idea struck him that a catalog of fuzzy objects that are fixed in the sky would help in finding comets. That's how it became known as M1, the first object in his now famous list. In 1913, Vesto Slipher studied it with spectroscopy, the first object of a series first studied that way. Analysis of photographs taken years apart showed, in 1921, that it is expanding. Backtracing the expansion suggested it must have been visible about 900 years earlier. Chinese astronomers recorded a daytime star in the same part of the sky in 1054. In 1928, a quest to match similar objects with historic observations resulted in 7 others. The star that exploded in an electron capture supernova was 9 to 11 solar masses. It left behind a central pulsar which was detected in 1968. And that's the term of the month, Crab Nebula.
Welcome back. Next, Doug is going to take us into his digital darkroom. Doug, can you please give our viewers some background on what they're going to be seeing next?
Yeah, what I'm going to be showing you is simple processing techniques for this deep sky images that I collect. And it will be not very sophisticated relative to others that use a lot of other techniques that I haven't used yet. So it'll be a basic stack of raw images and how I process them. And then the second part of the show is I'll show how to stack a comet set of data. So that's what we're going to be doing there. Okay.
All right, well, let's take a look.
Meant to do. There we go, M1. So I'm going to pull these 15 up. It's down here at the bottom, and there should be 15 of them. So when I check this, check all, it should pop up here and say light frames 15. Good. So that's what we want. Now, if you look at the raw data, I'm looking at the raw data right now. This is what a single frame looks like. And I'll maximize this now. So a single frame looks like unstretched or anything from the FITS file. So this is what the raw data looks like. Oops. Gotta make sure we do this right here. There we go. This is what the raw data looks like. Hi, Diane. This is the crab then. Raw data, unstretched, unprocessed, just a single frame. And I'm looking at all these right here. So they look okay. We're going to use them all. So at this point, they're ready to go. I'm going to say register, and I'm going to say use 100% of the pictures and stack them. Be stacked. So I've taken all 15 frames and put them together. And when they stack using an average or a median, depending on what you want to how you want to do it. They don't add data. They don't add because if you did that, after 20 frames, your entire screen would be white. They average the values. They average the values out. So there's the stack image there. If you remember the single frames that we showed you, they were FITS files. This is a stack and it's in color. Okay, so that's before I even do any processing. That's actually kind of nice. Now I'm going to go over to PixInsight. And we're going to maximize this guy, and we're going to open that file. Now when it comes in here, it'll be the raw stack with no processing, so it's going to be dark. And I'm going to show you something. I'm going to do an auto stretch, which means it's going to maximize the stretch without any intervention. It's an automatic auto stretch. And what you're going to see is that it's going to have this big old green background, and that's because it's an RGB Bayer matrix. Two greens with an R and a red and a blue. And that's how you basically it comes out when it's debayered. So what we'll do is we're going to take this and we're going to apply the simplest case is we're going to apply automatic background extract, which is basically does a color balance, a somewhat color balance, but it normalizes the image and takes out some of the gradients. So let's go ahead and hit this, and then we'll see what it looks like. It's going to create a new file in memory. Hopefully you can all see this okay. Okay, so it just created a new one. I'm going to do an auto stretch on this. And there you go. So the green's gone. Most of the gradients are gone. This is a little bit overexposed as far as stretching is concerned, but that's a max stretch. And that I do that real quick just to see how it worked out. And this will be fine. There's another couple of tech tools called photometric color calibration. I will use that to get a better color balance because what it does is it uses the stars in the field of view against a database that has photometric data for a lot of the stars and uses a reference point to give a better true color calibration of the object and the surrounding stars. But the simplest thing is this auto background extract gets the color balance somewhat close. Now we'll minimize this. I'm going to do one other thing. Now I'll do that in a minute. I can show you how I can back up. So we'll go to histogram now. So we've done the auto background extract. I should show you the color calibration. I'll show you what that does. So let me do that. So I'll bring up color calibration. I'm going to do the simple color calibration. And what that is you identify an area of the screen that you want as your primary color and then your background color. So I'm going to pick Crab Nebula and some of its surrounding area. In fact, I'm going to move it. Oops. That's not what I wanted. Hang on a second here. Delete all. All right, so I'm going to pick that star, and this object as part of the foreground. And then I'm going to pick a small area over here that's kind of part of the background. And then I'm going to go into the color calibration tool and identify those for this tool. Preview 1, preview 2, and then we'll just hit the little rectangle or the square and say go. So it's going to go out here and it's going to do some magic. Okay, and now when I auto stretch it, we'll see what it looks like. Now what it did, it moved it a little bit into the blue, out of the green into the blue. So that background is actually a little bit more, it's subtle, but it is, I can tell that it did change it. It's got a little bit more blue in it now. So if you like that, again, when you're processing data and you're a different user, five different people processing the same data, probably will not get the same results. A lot of this is art. So anyhow, I'm going to turn off the auto stretch, and then we'll do an actual stretch, and that's with the histogram here. So you'll notice I'm going to bring these little arrows that are in the graph. I'm going to use them to stretch the data here. Hit there. Okay, so now we got that so far. I'm going to bring up the bottom a little bit to get it darker. Bring the top down to get a little lighter. As you can see, you can start seeing the filaments in the crab now starting to show up really kind of nice with a reasonable color balance. It's not purple, it's not green, it's kind of a reddish that you would expect. Yeah. Maybe we'll go right about there. So this is art too. Do you want to have it real bright in the background, or you want to have it real dark? So you kind of pick a spot that you think is reasonable. Again, that's art. So I like the little darker background as long as I don't lose too much of the data of the nebula itself. So I'll hit that. Okay, so that's the histogram, simple stretch, and we're going to go to the curve transformation. We'll do curve transformation here. And what I'm going to do here is I'm going to use the saturation. So watch the color in the nebula as I move this. See how I can increase the saturation of the colors of each of the objects, including the stars. I mean, the stars, the red stars are getting really reddish orange, and the blue stars are getting bluer. The red in the nebula is getting redder. I can make this so extreme that it looks ridiculous. It looks clownish. So there's a nice clownish look at it, right? But what I like to do is keep that a little more subtle. So I've increased it just a bit to get so you can tell there's color in the stars. And I usually hit it right there at this one spot almost every time because that's kind of how I like it to look. In fact, the blues in the nebula comes out a little bit too. So if you notice in the histogram, the blue spread out and dropped down. So there's a lot more blue in here now than there was before. And there's not much more I do in the color. Sometimes I may mess with the luminance a little bit just to brighten it up or darken up the background. So you can play with this and do all kinds of stuff. There's here I'll make it really dark, right? Really dark background. Again, this in my mind, this is all personal preference. How do you want it to be rendered? So I like a little bit darker background, so I did that. And if you saturate the top end a little too much, it blows out the middle of the nebula. So you want to be kind of careful about that. You know. But we'll just darken it up just a bit. There, about right there. And what I usually do is I save it away as an EXIF file, so it saves all of the changes I made that I can use again from that point forward. And as a matter of fact, I've got one sitting here already, and I'm going to call it second processing because it's a new processing. And what I'm going to do is I'm going to pull up the other processing between the two, and we're going to look to see how much different I did from the last time. And I think I did it differently. So let's pull up the old one. Yeah, from a week ago. And let's compare the two. Okay. Yeah. See, I can already see what the difference is. Right? The new one I just did has got a darker background. Right? So that's what you call variability of the user. But it's got similar color. The background's a little darker in the one I just did than the one I published a week ago. And that's one of the problems. You get a human involved, it's never the same. This one looked kind of good for me when I looked at it last. Actually, this one looks different. The little color balance is a little different too. So anyhow, so those are the two things that can look different, just based on what you did that night. So that's basically that's the Crab Nebula. What I think I'll do is show you what I do with the comets. I will use the comet from last week, and we'll just go through a quick demo of that. Very first thing I do is I take the first frame of this object. I'm going to do an auto stretch so I can make sure I got the comet in here. So this is a raw debayered file. And I highlight the core of the comet. The first frame, and then I scroll down to the last frame, stretch that, zoom in, and then I highlight the core of that frame. Now the assumption is in here that every one of these frames are the same length, and they have approximately the same pause in between each of them, so that there's a delta value that's associated with every frame. If you mark the first and last one, it knows what to do with it. And once you do that, you hit the go button. It goes through all of those, and it registers the comet cores in all 10, 15 frames, whatever the number of frames are together, and writes those files out to what I call an alignment directory. Okay, so once the alignment's done, I'm going to close this. I go to a tool called image integration. In that tool, I pull up those alignment files, which are in this folder here. There's 10 of them. And I just hit the go button. And I'm going to let this one run. This is going to take all of those files, 10 files. It's now stacking those 10 files on the core of the comet. So if I do an auto stretch on this, as you can see, it's got green background just like we had before. So I'm going to go over here and I'm going to hit my automatic background extract on this file. And now I have this file, which is basically color balanced in the background. And you notice it's got the big central obstruction donut on it, and it's got the vignetting. That's because I didn't apply any flats to this. And I'm not making pretty pictures here. I'm just kind of collecting magnitude and motion data. If this comet ever gets to be where it's really beautiful, it's got a blue ion tail and kind of like Hale-Bopp, I'll do a little more work on presenting a pretty picture. But at that point, I'll be able to take really short exposures because it'll be so bright that I can apply darks and flats, and I don't even have to stack on the core necessarily. So, but this is what I do for the comet data. And I'll just pull this up in a regular histogram, and we'll stretch it somewhat. Like so. Kind of get a good dark background that I like. As you can see the coma is getting pretty significant, and there's a nice tail heading off to the 730 position. So we'll hit that. That looks okay. I'm going to pull up my color, our curve transformations here, and hit the saturation, reset this. And I might pull that up a little bit to show the colors of the stars a little bit better. And of course, the comet itself will get a lot greener. Anyhow, that's how I process a comet. Let me pull up the luminance here. In fact, if I look at the RGB, they're pretty stacked together there. Which is reasonable. The green's a little stronger on the vertical, but not as wide on the horizontal. But I'll go with the luminance here just to darken up the background just a tad. There we go. So there's a comet shot of Atlas. So that's my processing for comets.
What's up in the night sky for May 2020? The days get about a half an hour longer over the month of May in Michigan. The moon is full on the 7th, last quarter on the 14th, the new moon is on the 22nd, the first quarter is May 29th. On the 4th of May, Venus is in Taurus and sets late in the evening and it is magnitude 4.4, very bright. It's too close to the sun at the end of the month, but note Vesta is near the foot of Gemini. On the 31st of May, at the end of the month, at 10 p.m., Mercury has gone all the way from Aries to Gemini, having gone through superior conjunction on Star Wars Day. May the 4th be with you. The rest of the planets are also on May 31st, but at 4:45 in the morning. Jupiter is in Sagittarius and rises at midnight. It is an extremely bright -2.4. Saturn is in Capricornus. It rises also at midnight. It's magnitude 0.4, which is still pretty bright. Mars is in Mars is in Aquarius. It rises at 2:30 in the morning. It's magnitude 0. It's not bad. Then you'll need a decent star chart for Neptune. It's in Aquarius. It rises at 3 a.m. It's magnitude 7.9, so you'll need binoculars or a telescope. And that is what's up in the night sky for May of 2020. Remember, we don't charge for this show, but we may tax your brain.